All right, so let's look at our first example. First example is very similar to the warm-up that we did, and we looked at is square root of 5x minus 9 equals 11. And in all these problems, the main thing that you want to do is you want to isolate the radical. Isolate the radical expression. In this problem, it's already isolated. So I have the square root, that term by itself, because I want to set this up to get rid of that square root. And so it's already isolated. Now we're going to do the inverse operation, which is to raise everything to the second power or square both sides. So I'm going to square everything on the left, and I'm going to square everything on the right. If I square a square root, those are inverse operations. Therefore, we're going to go right back to what we started with, or just get the argument inside here, which is 5x minus 9. So we get 5x minus 9 equals 11 squared, which is 121. And then we can just solve it normally. So I can add 9 to both sides and get 130, and then divide by 5 to get 26 as an answer. So that's really it. Now there are obviously different types of equations here. You can have a radical with other things around it that you're going to have to isolate. So you could have a square root, you could have a cube root, you could have a fourth root. And not only that, you could just have something written not as a radical, but as a rational exponent. So I'll show you what I mean on this next slide. So here's some practice problems for you. You can go ahead and try these. All right, so if we go through these, I'll go through them one by one. So this one on the left, we have a cube root of x, and then minus 9 equals negative 10. So the cube root of x, we want to isolate that by itself. So I'm first going to add 9 to both sides and get the cube root of x by itself equals 8. And then since it's a cube root, I'm going to cube both sides. So I'm going to raise both sides to the 3. So therefore, this would become x equals, and then we need whatever 8 cubed is. So 8 cubed is 512. So there's my answer, is 512. Second one, we're going to kind of do like what we just did before, is just square both sides to get x plus 25 equals 16. And then we can subtract 25 on both sides. That would give us negative 9 for that. And then this last one, we'd first divide by 2 to get that radical by itself. So divide by 2, we'd be left with a cube root of x minus 3 equals just 2. And then we can do the inverse of this cube root by raising each side to the third power, and that would give us x minus 3 equals 8, and then we'd add 3 to both sides to get x equals 11. So there you have it. And I think we've done these types of equations, or at least a little bit, in a previous chapter. So again, all we're doing in these problems is we're isolating the radical, or the radical expression, and then taking the inverse of that, which is raising that expression to a number to get rid of that nth root. All right, so let's keep on going here. Here's example 2, and very similar to example 1, except that we're dealing with a rational exponent instead of it being written as a radical expression, like a root. It's written with a rational an exponent with a fraction in it. So the same principles apply here, though. We're still going to isolate. We're going to isolate, in this case, this isn't written as a radical expression. It's rational exponent technically, but you could rewrite it as a radical expression. nevertheless, you're going to isolate that. In this case, we'll say rational exponent expression. So same type of thing. I'm just trying to get whatever is being raised to this value by itself. So I'm just trying to get x raised to the 3/5 by itself. So therefore, to prep this, I'm going to divide by 7 because 7's not being raised to the 3/5, only x's. So therefore, I divide by 7. I get x raised to the 3/5 equals 8. And now I want to get that by itself. Right? So this is x raised to the 3/5. What are we going to have to raise both sides by to make this x to the first power? Well, the answer is I'm going to raise it to the 5/3 there. And the reason is, if you think about these exponent properties, if I have x to the 3/5 and that's raised to the reciprocal of 5/3, then I would multiply these numbers to get x to the 15/15, or x to the 1. And that's really what we're trying to get, is x to the 1 on both sides. So the trick here is to raise that side to the reciprocal of whatever the exponent is. So I'm going to raise the left to the 5/3, and I'm going to raise the right to the 5/3. And what happens here is that this just becomes x. That's x to the 1 basically. So this is x to the 8 raised to the 5/3. Now you could simply use a calculator and figure out what's 8 to the 5/3, and it's going to give you 32. You should also be able to use these exponent properties from what we learned before to figure out that this is equal to 32, because as in our warm-up, how would I rewrite 8 to the 5/3? Well, the bottom number here is a 3. That means that this is a cube root of 8 and then raised to the 5th. That's another way to write that same exact expression. And I know the cube root of 8, that's just 2. And so therefore this is 2 to the 5th, and I know 2 to the 5th is equal to 32. So the answer here is 32. Now I could just plug in 8 raised to the 5/3 in my calculator and do that. Sometimes you're going to have to do that because you won't have a perfect number that you're doing here. You won't have a perfect cube here, a perfect square, a perfect whatever you're dealing with, and you'll have to approximate the answer. But in this case, you definitely should be able to use your knowledge from before and rewrite this expression to get that 32. All right, so let's practice that. Well, actually, hold on a second. Go ahead and try that one as a practice. Go ahead and pause the video. Negative 2x to the 3/4 equals negative 16. All right, so this one, same as before, you want to get x to the 3/4, x to the 3/4 by itself. So therefore, we're going to start by dividing by negative 2. So we have x to the 3/4 equals 8. And then since this is raised to the 3/4, I'm going to raise everything to the 4/3 to get rid of that exponent of 3/4. So I'm going to raise the left and the right by 4/3, and therefore I have x, my answer, is equal to 8 to the 4/3. And again, you should be able to tell me what that is without using a calculator, which is going to be 16. But you should write that out. So this is the same thing as the cube root of 8, and then all raised to the 4th. So the cube root of 8 is 2, and 2 to the 4th is equal to 16. So x equals 16 here.